All right, this is section 5.6, direct variation. And so today what I'm going to do is I'm going to give you some vocab words that are new. But the ideas behind these vocab words are not new. There's something we've been doing really all chapter long, which is proportions. Okay. So this is not going to make a whole lot of sense when I say this, but when I show you what we're doing, I think it's going to make a lot more sense. Two quantities, x and y, show direct variation when y equals kx. When that equation can be written y equals kx, where k is not equal to 0. The number k is called the constant of proportionality. You know it by another name. We'll get to that in a second. Two quantities, x and y, show direct variation, mean they are directly related when y equals kx. For example, if I gave you two ratios, if I gave you the ratio of 5:10 and 15:30, can you tell me what I would have to multiply 5 by to get to 10? 2. What would I have to multiply 15 by to get to 30? That number is the same, right? What's that tell you? Those ratios are proportional. Exactly. So that number that makes them proportional, the fact that we were timesing by 2, we call that our constant proportionality because it was always 2. It'll always be 2. Okay, so we actually have a fancy way of describing that. Okay, you know that 2 is another word, or that 2. You know that k is a different word. You know that k as our slope. Whoa, that's a really thick line. Let's change that. K is our slope. Okay, which is why we're talking about this after we just got done taking a slope quiz. Okay, the graph of y equals kx, which is an equation. It's an equation of a line. The graph of y equals kx is a line that has a slope of k. So what was k in the last example? What would we say k was? Now, that example I gave you, we said k was 2, right? Well, okay. That's what it's like. That's what the graph of that proportion looks like. Whatever the x value is, times it by 2, that gives you the y value. What special point does this line happen to go through? 0, 0. What's that point called? 0, 0. The origin, yes. So the graph of y equals kx is a line that has a slope of k. In this example, that slope is 2. That passes through the origin, 0, 0. Have we looked at any lines this chapter that have gone through the origin? Almost all of them have. In fact, before you took your quiz on Friday, we looked at this example together. Do you remember it? The crosswalk example we did before we took our quiz? Yeah. Daytime cycles versus nighttime cycles. Did you notice both those lines went through the origin? Okay. So when we were trying to find out how many times the light cycles during the day, we looked at this coordinate here. And what did you say? What did you say we had to do to find our unit rate? Maddie? What do we divide it? You're right. What's 80 divided by 2? 40. 40. Okay. So last week we just said that the slope is 40, the unit rate's 40. Today we're going to say that k is 40. So what's the k value of this line, the blue one? 30. Oh, you guys can already find k. Excellent. So it's a new vocab definition. It's a new constant proportionality, something I haven't said before to you guys. But the idea behind it, what we've been doing, is the same. Now, can I use this point 4,160 to get a k of 40? Yeah, in fact, if I divide any point on that line, I'll get 40. What about the blue? What's 150 divided by 5? It's 30. I can use any point in the blue line and I'll get 30. The fact that I keep getting the same number every time I divide means that the number is a constant. And that's what k stands for. K is the constant proportionality. They just use, it's interesting they use k for constant, right? Well, there's a reason they don't. And so next year, you guys will talk more lines and more equations of lines. And so one of the variables they already use is c. And so they had to come up with a different variable for this one. And they called it k for constant, since it makes the same sound, but C is already used, so they couldn't use C. Next year, you guys won't call it K at all. You'll call it M. M will stand for slope next year. Good question. I would love to just say M now, but then when you get to the homework and it just keeps saying K, 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 it would probably be confusing if I called it M, 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 M the whole time, right? So you'll get to that next year. It's really, I like using slope next year even more than I like using it this year. Okay. So when X and Y show a direct variation, why do we have to know this? Because if they show a direct variation, we would say that that's a proportional relationship. That's a proportional relationship. To say that we have a direct variation means that we have a proportional relationship. Those two words are one and the same. And here's the direct variation equation, y equals kx. So what we're going to do today is we're going to find out what k is. And as you guys just proved, finding k is not very difficult to do. And then we're going to take k and we're going to plug it into that equation. And we're just going to write y equals, well, in this case, y equals 2x, because our k value is 2 here. That's what we're doing today. It's not really a hard lesson. It's just new idea, new vocab words for something we've already been using that we haven't called it k before. We've been calling it slope. Okay. So other ways to say that x and y show direct variation, or that y varies directly with x and x and y are directly proportional. And so you might see these words come up in this section. Okay, what does a direct variation look like? Well, if you look at a graph, you're going to see a line, and that line's going to pass through the origin, just like this one did. If you have a line and it passes through the origin, you have a direct variation, which means every point on that line is proportional to all the other points. But we don't always have a graph. So algebraically, if I'm like, for example, let's say I just have a chart like this. Algebraically, I'm going to see if it's a direct variation, I'm going to see if x and y are proportional. And how do I do that? Do you remember back earlier in this chapter, we said there were 3 ways that you could tell 2 ratios were proportional. What are those 3 ways? Dividing is one of them. Cross multiplying is another one. What's the one that nobody really likes to use? Reducing. Okay. So you might remember me saying this earlier in the chapter. If you have more than 2 ratios, you shouldn't use cross products, although it's my favorite to use. You shouldn't use it if you have more than 2. If you have more than 2 ratios, you should use the dividing method, which is 1/8 instead. And that's what we're going to do today. We're going to divide. Do you remember, I made such a big deal about this. Do you remember what letter I said has to go on top? Was it X or Y? It was the Y that had to go on top. And the reason for that is because now we know what slope is. Slope is the rise. What's your rise axis? The Y over the run axis, which is the X. Yep, change in Y over the change in X. That's why Y has to go on top. But again, we've done that before. So this isn't new. This is not new. So what is K? Well, we know it's the constant, but what is that? Well, another way of saying K is the unit rate. It's actually the first thing we did this chapter was find unit rates. So K is the unit rate. K is also the slope. And K is what you get when you do Y divided by X. So for this example here with the tickets, what's the K value? What are you going to get when you do Y divided by X? 6 every time. 12 divided by 2, 6. 24 divided by 4, 6. 60 divided by 10. Oh, scary. So we'd say our K value is $6 per ticket. Since K is a unit rate, we can use 2 labels and we can say it's $6 per ticket. Now let's graph these points on the graph. I want you to go to 2 on the x-axis. That's the tickets axis. 2 tickets cost $12. So plot the point 212. 4 tickets cost $24. Plot the point 424. Now, I can't plot the point 1060. Why not? Yeah, the axis doesn't go up to 60 on the y-axis or over to x to 10 on the x-axis. But I only need 2 points to graph a line. So watch what happens when I connect these 2 points. What special point does it go through? 0, 0. Yeah. So if I'm looking at a graph, if it's proportional, it should always go through the origin. If I'm not looking at the graph, or even if I am, if it's proportional, I should get the same value every single time when I do y divided by x. And that same constant value that I constantly get all the constant time is my constant proportionality, which is the k value, which is your slope, which is your unit rate. Okay, now this is the only new thing we're going to do today. You ready for this? When you find out what k is, they're going to ask you to write the direct variation equation, which is y equals kx. That's the equation of the actual line, just like this line up here was y equals 2x. They're going to ask us to write that. So once you find out what k is, I just need you to plug k in right there. We're going to leave y, we're going to leave x alone. I colored k purple because it's the only one we actually put a number in for. What was our k in this last example? 6. So I'm going to write y equals 6x. Now, graphing equations is something you're going to do a whole lot of next year. But let me just show you why this makes sense. What did X stand for again? Tickets. So if I buy 1 ticket, I should plug 1 in for X. What's 1 times 6? 6. So Y is 6. Y is my cost. What if I bought 5 tickets? What's 5 times 6? 30. So Y would be 30. Does that make sense that if I plug in a value for Y and plug in a value for X, that can tell me whether, if I want to know what my cost is, take the number of tickets and times by 6. If you want to know how many tickets you bought, let's say you spent $240. You want to know how many tickets you bought? Well, then divide it by 6. That's how many tickets you bought, right? Just the equation works both ways. That's really the only new thing we're going to do today is we're going to write the equation after we find out what that k value is. So first, a few examples here. Tell whether x and y are in a proportional relationship. Are in proportional relationships, which means are they direct variations? If so, what is the direct variation equation? Example A. Let's see how well you were paying attention. Is this a direct variation? Maddie, you're nodding your head. Why do you say it's a direct variation? Wow. Speaking about going through the origin, I think something, you catch that on video? Sheesh. Needs to go back to the origin, is what that needs to do. Sheesh. Thank you, Maddie. Yes. Example A is a direct variation because to be a direct variation, you have to be a line and you have to pass through the origin. And that's what we have here. We have a line passing through the origin. So what I want you to do then is if it is a direct variation, I need you to tell me what the k is then. What's k? Remember, k is y divided by x. So what do you get for k each time? 10. Nice job, Annie. You get 10 each time. So I could use this point, right? 10 divided by 1 is 10. I could use this point. 30 divided by 3 is 10. I could use this point. 60 divided by 6 is 10. I get the same thing every time. So that's also proof that it's proportional. So it's going to the origin. So all those points will give you the same answer, which is 10. And let's be specific here. If we were to label this, it'd be 10. What's the y label? What's the y label? What's the y-axis labeled in? Dollars per hour. Yeah. Remember the k values are unit rate. So the same thing that you did to find the unit rate on this example we looked at with the crosswalks on Friday, it's the same thing we're doing today. Y divided by X. This time, Y divided by X gave us 40 for the red line and 30 for the blue line. Well, in this problem, it gives us 10. I'm doing the same thing. Okay, what's the equation then? Remember the direct variation equation, just got to take that K and plug it in. What's my equation going to be? Anybody want to try it? I know it's hard. Maddie?
Y equals 10x.
Y equals 10x. That's it. And again, that means take whatever X is, times it by 10, and that'll give you Y. $10 per hour. What about example B? Is that a direct variation? Ashley, why not? Yeah, exactly. Really easy to tell when they give you the graph because all you have to determine is this a line and is it going through the origin? And Ashley's right. This one's not going through the origin, so it has no chance. So I can't write the direct variation equation. I also can't find the K value because none of them will be constant. Like on this example, every single time I divide, I get 10 every time. But in this example, can you tell me what 30 divided by 1 is? 30. And what about 15 divided by 4? Not 30, is it? Yeah, I'm not going to get the same. I have to get the same answer if it's proportional, and this one's not. So if it's not proportional, it's not in direct variation. Those words are the same thing. If you look it up in the dictionary, proportional, it'll say C direct variation. If you look up direct variation in the dictionary, it'll say C proportional. That's not true. It won't say that. Thomas, how you doing back there? Good. All right, Thomas, tell me if this is a direct variation or not. I can't hear you. Is not a direct variation. You are correct. Can you tell me how you know? Doesn't go through the origin. It has an initial value. So I don't know if it was this class or a different class. Do you remember me talking about last week? We used the example of going to the Howard County Fair. Did I use this example with you guys? Okay. So we were determining whether things were proportional. So I said, let's say I go to the Howard County Fair. I pay $10 to park. So I think, did I use this example with you guys? Okay. So I don't pay to get in, but I had to pay $10 to park. And then I paid $2 to go on one ride. Seems like a fair price. I think it's actually more than that in reality. So how much have I spent total? $12. How many rides have I gone on? Is it fair to say that I spent $12, each ride's $12 per ride? But that's what my Y divided by X gives me. Why is it not $12 per ride? I spent $10 before I even got in, right? So that's an example of a not proportional relationship. That if I didn't have to park, or well, if I didn't have to pay for parking, I would have only spent $2 per ride. And that's the right? That's the relationship. $2 per ride is correct. And so if I have an initial fee, that throws off my proportional relationship. Look at this one here, tickets. You bought 0 tickets, you paid $10. Does that make sense? No, no one's going to pay $10 for 0 tickets. But what that means is whatever website this is using charges you an extra $10 just for using its website. And so that's not proportional. If I buy 1 ticket and I spend, let's just call that 25. It's not $25 per ticket. It's actually 15. I had to pay an extra 10 just to use the website. And so that's not proportional. And so that's why I'm not getting, 100 divided by 6 is not the same as 40 divided by 2. What is 40 divided by 2? 20. 100 divided by 6 is 16.6 repeating. Those are not the same. So this is not proportional. Or you can just do what Thomas said. Doesn't go through the origin. So it's got no chance. What about this one? Is that proportional? Yeah, so it's a direct variation. It's going through the origin. What's the K value then? If I'm looking for the cost of 1 pizza, since I know it's a unit rate, I would say it's somewhere a little bit more than 5. I don't know, was that 550? 6, 650, 675, 575, 618, $5.99. You know how I can be sure? I want you to find a point on this line that you are 99% positive would be on this line. Do you see one? If you're in my extension class, you did something like this last week. Do you see a point that's a really good point to use? Ashlyn, do you see it? There you go. Nice job. The point 530 is on the line. I've just put an X there. So Ashlyn, what is 30 divided by 5? 6. Remember, it's Y divided by X, not X divided by Y. And so we get 6. So our K value is 6. $6 per pizza. So Ashlyn, I'm going to have you finish this one. If the K value is 6, what's the direct variation equation? Y equals, that's exactly right. Y equals 6X. Just got to take the K value and insert it in where the K goes. Thomas? Yeah. Now, sometimes instead of giving you a graph, they're going to give you a chart like this, and they're going to make you graph it yourself. So here's my question to you. I know we're going to graph this here in a second. Do I have to graph it? All I have to do is Y divided by X, don't I? That's going to tell me if it's proportional or not. So before I do the graphing, and I'll do the graphing in a minute, let's just start down here at the end. Y divided by X. What's 4 divided by 4? 1. What's 2 divided by 3? 2 divided by 3? How about the fraction 2/3? Does that work? What's 0 divided by 2? 0. And -2 divided by 1? -2 divided by 1? Are those all the same? This isn't going to be proportional, is it? So when I graph this, are you going to see it go through the origin? No. So watch what happens when we graph it. We'll start with the very first one. -2, 1. -2. I'm sorry, it's 1, -2. I read the Y's first. It's 1, -2, which is going to put us right here. Then we have the point 2, 0, which is going to put us right here. Then we have the point 3, 2, which is going to put us right here. Then we have the point 4, 4, which is right there. Now, do they form a line? Yeah, they form a line. That wasn't the only restriction, though. You had to be a line, and your line had to go through the origin, and that's not happening here. Now, the nice thing is that we don't actually have to rely on our graphing skills. All we have to do is divide and see if everything's proportional. And if it's not, then we kind of wasted our time. Now, the reason I'm giving you this and practicing the graphing is because you'll have some problems on tonight's homework where you have to graph the points to see if they line up. Like there's no getting around it, but you can actually tell it's not proportional before you graph just by dividing. Now, this next graph definitely goes through the origin, doesn't it? What's 2 divided by 2? 1. What's 4 divided by 4? What's 6 divided by 6? I keep getting the same answer, don't I? So what's that constant answer? 1. So K is equal to 1. When you're using that dividing method, not only does it tell you if it's proportional, in this case, yes, it is, it also tells you what your K is. Okay, well, let's graph this. 0, 0, 2, 2, 4, 4, 6, 6. Graph it right. Should make a line. And that line should go to the origin. So this is a direct variation. The last one was, I didn't answer the last one. Last one was no. No, the last one's not a direct variation. This one is. DV stands for direct variation. This one is a direct variation. What would the direct variation equation be? Come on, someone other than Maddie and Ashlyn should know this. What's the direct variation equation then? Take the K and plug it in right there. Y equals 1x. That's right. So the equation will be Y equals 1x, or just Y equals x. You don't actually have to write the one. Y equals x would work as well. Does it make sense? It says if the equation of this line is Y equals x, that means every x is the same as the Y. And look at this. 0, 0, 2, 2, 4, 4, 6, 6. Every x is the same as the Y. Okay, training wheels are coming off now. I'm taking away the graphs. Obviously, it's super easy when you're looking at a graph to see if it goes to the origin. I'm going to ask you now if it goes to the origin without looking. We just have the information. We just have the points. So if you can't tell if the line passes through the origin, see if X and Y are proportional by dividing. And what's the order we have to divide? Y over X. That's exactly right. Rise over run. Change in Y over change in X. Look at example C here. Negative, I got to do Y divided by X. So -2 divided by 0. Can you divide by 0? Okay, it's undefined. Skip it. 1 divided by 1. 4 divided by 2. Stop. Those aren't the same. Is this a direct variation? Nope, which means I can't, not on K value. Yes. Sure. Hello. Yep. Okay. Bye. Okay, example D. 4 divided by 1. 8 divided by 2. 12 divided by 3. 16 divided by 4. Is this a direct variation? Yep. What's the K value? 4. That constant number I keep getting, right? All right. Somebody new. Parker, tell me what the direct variation equation is then. That's right. That's right. That's it. All right. Last one. 4 divided by -2. -2. Now, by the way, if you do X divided by Y, you'll be able to tell if it's proportional or not, but it won't give you the right K value. So make sure you're doing Y first when you're dividing. What's 2 divided by -1? -2. Can't do 0 divided by 0, but good thing it goes through the origin. That has to happen, right? So that's good. What's 2 divided by 1? Oh. Is this a direct variation? No, it's not. It's a good thing we checked all the points. This one's not a direct variation. Actually, if I were to plot the points, this is what I would see. Here's the origin, and then makes like a backwards check mark. So it's not a line. It takes a different angle. So it's not a line. All right. The table shows the area in square feet that a robotic vacuum cleaner cleans in X minutes. Tell whether X and Y are directly proportional, and then write the equation that represents that line. If it's directly proportional, all these will give you the same answer, right? Okay. So let's start with the bottom. What's 32 divided by 2? 16. 24 divided by 3/2 is the same as 24. I was going to use keep change flip, but do you know what 3/2 is as a decimal? 1.5. So instead of using keep change flip, why don't we just call this 1.5? 24. Does anyone have their calculator with them? You have yours? Can you tell me what 24 divided by 1.5 is? I'm hoping we get 16, otherwise this stands no chance. 16. Okay, hang on. We'll finish this. 16 divided by 1. 16. And then 8 divided by 0.5. I bet you a half goes into 8 16 times. What do you think?
Yeah.
So what's our K value? 16. What's our direct variation equation? Y equals 16x. And I am going to erase this and present to you the graph of this. Oh, does it go through the origin? It does. Yep. So it's a line, goes to the origin. So we unfortunately finished the same spot period 1 did. So we'll finish up with these last 2 problems tomorrow. 5.6 is due Wednesday, and I'll see you guys later. Have a great day.